Maybe they still sleeping or something. Is that right, Tanvi? Tanvi is still sleepy also, but she's here. Let's begin with this one. Last time I gave you one problem. Remember, I gave you the problem of 2. Is that this one? Yeah. I gave you 2x1, no, 2x plus 6y plus what? 3z plus z plus 2w equal to 5. That problem. Did you give a try? Hello, so quiet. Did you give a try? Anybody have done this already? Can you type O for me? You can type O. I did. O. Did you do it? Can you hear me? Yeah, I turn on everything. And anybody did this problem? I tried, but can't have the same answer like you. No. Okay, you know what? Thanks. Let's see this together. Did you get, once you rewrite your system of equations in terms of augmented matrix, the front term here, the first 4 columns here comes from the coefficient terms, and we call this is matrix A. And the last column, it has to be the last column. This is from the term on the right hand side. Just follow like each line like this. Okay, let's begin this. I ask you to write in terms of reduced row echelon form. How are we going to do it? First of all, remember the leading one. The leading one, that means when you walk to this, if it's not 0, it has to be 1. And you found this one is not 0, but it's 2. We don't want it. How are we going to do that? I can see this can make it become 1 so easy. So I just divide by 2. Through this equation, that means through the whole row 1. So you divide it by 2, you get 1, 3, 1/2, 1, and 5/2. You see that? And once again, once you have this number to be leading one, follow the rule of row echelon form. You need to get the terms below that to be zeros. And we have only 2 more rows. So this 0 already, done. Move on to the next row. The next row, once you come in, if it's not 0, the next number, the first number that you found, supposed to be 1. But it's 3. How are we going to make it becomes 1? Because here 0 already. Therefore, I just divide the second row here by 3. So I get 1, 1/3, 4/3, and 1/3 like this. And I keep the last row the same. Alright. So now we have leading 1 here, which is good. And we have leading 1 here. To make it become reduced, okay, keep this in mind. If I ask you just to write in terms of row echelon form. Row echelon form, you only need to make the number below here become 0. But now we step more than that. We go a little bit further down there. So we ask you to do reduced row echelon form. Once you found the leading one, the other numbers, you see, other numbers in the same column, others supposed to be 0. So I found my leading one here. Therefore, this number and this number need to be 0. How are we going to do that? We're going to use the row that we have leading 1 here to cancel out this term and this term. Therefore, in row 1, I just take R1 minus 3 R2. You see, R1 is 3 and R2, to make it become 0, I have to subtract 3 of this number. So I get the whole R1 subtract 3 of R2. And this is what I get for R1. R2 we keep the same. And then R3. In R3, we need to make this term become 0 once again. So I just take R3 minus 3 R2. See? And this term becomes 0. All right. Now the first column here is 5. We have leading 1. The rest will be 0. The second row here we have leading 1. Here will be 0. Then the third row. Once you walk in here, if the number that you found, the first number is not 0, that number needs to be 1. But right now we have negative 2. So easy. So I just divide through the last row by negative 2. And this is what we get. Therefore, right now, I have what? I have this term, I have 3 leading 1, this one, and this one. All right. Once we have this, how are we going to write down the solution? Okay, let's rewrite it in terms of linear equation. So this one, I use x1, x2, I mean x1 corresponding to x, x2 just y, x3 to be z, and x4 will be w, just like that. So here will be x1, we don't have x2, and minus 1/2 x3 is equal to negative 9/2. And this one, we have x2, you see, plus 3, plus 1/3 x3 is equal to 3. And the last one, x4, equal to minus 2. After this, we just rearrange the term and try to use backward substitution. But you can see x1 and x2 depend on x3, right? We can rewrite in this form. So x1 depends on the value of x3, x2 depends on the value of x3. And when you have these, actually we have the name for it. The column that has leading 1. Okay, so now we have the first column, the second column, and the last column here. We have 3 columns contain leading 1s. Therefore, these 3 columns represents the main variable. How about the column that we don't have leading 1? The column that we don't have leading 1 in there is called free variable. And right now we have only 1 column. If this one represents x1, x2, this one x3, so now we can say that x1, x2, and x4 are main variable. And x3 will be what? Free variable. Okay, once again, now we have the main variable and the free variable. If I ask you how many free variables in this system, you just say 1. How you determine it? Okay, how you determine it? You can see that the number, okay, I summarize it for you. The number of main variable equal to the number of column containing, I don't see that, leading 1. Okay, the number of main variables equal to the number of column containing leading 1. How about the number of free variables? Okay, you can keep this, so at least you can summarize it. For some reason, how come this one? The number of free variable equal to the number of column have no leading one. All right. So like this example, I'm gonna summarize this in like the documents after this for you. So now you just see here first. So when we have this, you see, I just write down the solution will be x1, x2, x3, x4. And you know that x1 can be written in this form, x2 can be written in this form. And x3 we don't know, it's a free variable, so it's freedom for x3. You just write x3. And then x4 fixed, it's equal to -2. After that, I just split this form into two groups. The first term, just the term involving with x3. So I have x3 and here gonna be what? The coefficients of x3. So 1/2, -1/3, and 1. The last term we don't have x3, so 0. And then we keep the constant term the same, but together. So we're gonna have -9/2, 3, 0, and -2. You see that? So now our solution depends on x3, right? And x3 is a free variable. Every time you have free variable in your system, that means we have infinitely many solutions. All right? Once you have infinitely many solutions, the thing that I have here, I only set the value because we have x4 equal to -2. You see that? And I just pick up one number of x3, which this time I just choose x3 equal to 2. Once I know x3 is 2, I just plug in here. So I get x1 to be -7/2 and x2 equal to 7/3. It's just one choice of x3. You don't have to choose this one. Actually, if you can write solution in this form, you're done. Okay, let's get some more idea about this. I have to kind of like focus on reduced echelon form and row echelon form. I mean row echelon form and reduced row echelon form before I move on to the next topic, which is gonna be vector space. If you can't get the right reduced row echelon form, you cannot tell me the rank, the nullity, the dimension. It's gonna be so many problems come after that. Therefore, I just have to, go over this again to make sure that you understand all the step of getting the row echelon form. Okay, let's see here one more time. What do we have? Nothing much today. We have to talk about row echelon form and reduced row echelon form. All right. Let me keep you here. For elementary row operation, you see, if you only do the row operation, this thing is a rule. You can multiply one equation by non-zero constant. You can add one equation to another, just like we have like 2r3 minus r1, something like that. And back to this example, this is how you write augmented matrix, okay? Every time you have the system, you need to write in terms of augmented matrix, and this is called the augmented matrix. The first row comes from the first equation, but we bring only the constant in front of each variable and the term on the right-hand side, you see? And here will be from equation 2, and this from equation 3. After that, okay, and definition here is to say, this above matrix is called the augmented matrix of the system. You need to be able to write augmented matrix first. After that, you follow the row operation. Row operation means you can multiply equation by non-zero constant. Okay, I emphasize non-zero. Don't multiply 0 with any row or any column in this word. Otherwise, you won't get any result. And then you can add one equation to another. After that, you can follow the operation on the augmented matrix here. Multiply a row by a non-zero constant. You see, each row represents equation, right? Same thing when you multiply an equation and you multiply a row. It's the same idea. Then add a multiple of one row to another. After that, we also have operation type, like you can interchange any two rows. The system will still be consistent and nothing gonna change about the solution. What else? If you have the whole row contains zeros, move it down to the bottom one. And we say that these three operation here is called elementary row operations. You see, this called row operation. Let's see this example. From this example, we have augmented matrix here. Comes from this system, you see. 1, 2, minus 1, 5. Here we go, we get the first row. 3, 1, negative 2, 9. The second row. Minus 1, 4, 2, 0. The last row. I'm sorry for some of you who kind of like, fully understand of this already. I have to make sure that I don't leave anybody behind before I move on. If I mention about row echelon form, I mentioned about reduce row echelon form. You have to recall the technique. You need to be able to think of it right away. All right. So once we have this, first of all, we have leading one here. You see that? It's already done. Therefore, to get reduced row echelon form, this one they just do row echelon form. So once you have leading one, the two numbers below one here, you're supposed to make it become 0. The first step, they're dealing with the last row. They want to make this term become 0 first. So they just add them up between row 1 and row 3. And this is what they get. You see, add row 1 and row 3 and you put in row 3. So 1 minus 1, 0. 2 plus 4, 6. Minus 1 plus 2, 1. 5 plus 0, 5. Next, you want to get rid of this number using R1, right? So R2 comes from R2 minus 3R1. R2 minus 3 times the whole thing in R1. And this is what we got. Here we go. We got leading one, 0, 0 below that. Good to go. Move on to the next row. Once you move in here, the next row, if the first number that is not 0, you found it, supposed to be 1. How are we going to do that? So to make it becomes 1, you can deal with anything here that you can make, like you can divide through this by negative 5 to get 1 or so. But no, we don't want to do that. Sometimes if you can avoid dealing with the fraction, let's do it. Otherwise, you can make easy typo from calculating the adding or subtraction of two fractions, right? So to do it here, we can say this one, if you add the last two rows together, this term can be 1 easily. So in R2, we just get R2 plus R1, and this is what we got. So now to make just row echelon form, you need to make this term become 0. How to do that? So easy, just R3 subtract 6R2, right? And here we go, we get 0 already. All right, so now the number below here becomes 0. We can go back this. So we have, rewrite it back in terms of equation. x1 plus, 1x plus 2y minus 1z equal to 5. And this one, we don't have x, we have 1y plus 2z equal to minus 1. And z equal to minus 1. If you have this kind of solution, you see, you can use backward substitution. You know z, you plug z in here, you know y. When you know z, you know y, you plug z and y here, you get x. And here we go, this is what we got. We get one solution, this one unique solution. And note here, the matrix obtained in step 5, like this, is called row echelon form. Okay. Let's see. how we explain the row echelon form. First of all, the first non-zero entry, the first number in each row, if you found it, it has to be 1, and that one is called leading one. Sometimes like in other documents, sometimes they use the word pivot, P-I-V-O-T, pivot. Pivot, leading one, exactly the same thing. It depends on the document. If a column contains a leading one, then every entry of column below the leading one is 0. Once you found the leading one in this row, then you consider the column that contains leading one. The number below the leading one supposed to be 0. You see, this is the meaning of the second one. Number 3, as we move downwards through the rows of the matrix, leading one moves from left to right. You see that? Because the leading one here, so the number below must be 0. And then when you go to the next row, the leading one cannot be below here, right? Because the number below the first leading one here, the previous row is supposed to be 0. So the leading one gonna keep, move backward to the right. And this is the meaning of here. Move from left to right. Any rows consisting entirely of zeros are grouped together at the bottom of the matrix. If the whole row consists of only number 0, move the whole row that consists of the 0 rows down to the bottom. That's the meaning. If you can see these 4 properties here satisfy in your matrix, then you say this one is already in the form of row echelon form. All right. And here will be the strategy that we talked about last time, it should be fine about here. Let's see here, this example. One more example about row echelon form. Reduce A to row echelon form. Okay, we have leading one here. So the number below here is supposed to be 0. So what I do to R2 here is just use R2 minus 2R1. And then in R3, we just take R3 minus R1. You see? And this is what we got. When you when you subtract the multiplication of 2 to R1, you have to do it like single element here in the same position. And then get a leading one as the second entry of the second row. Here we go, it's 3, so we don't want it. We want to make it 1. So we just, add R2 and R3 together. So here it's gonna be 1. Here we go, keep R3 the same. After that, once we found our leading one in the second row, then the number below here is supposed to be 0, right? Here we go. How we're gonna cancel this? So we get R3 minus plus 2R2. So here becomes 0. Here we go. Now the last row here 11. So we just divide through this with 11 to get another leading one. Here we go. This one is called row echelon form. Let me mention about this a little bit. You see here we have how many variables? We have 4 variables, x, y, z, w, right? And now we have only 3 columns consist of leading one. Let's go back to the free variable and the main variable. So now we have 3 main variables, x, y, z. The last column here we don't have leading one. Therefore, now we have x4 or w represents the only free variable in this system. And let's see this definition. Now you know the rank. We're going to talk about the rank again shortly. The rank A, the rank of this matrix, is the number of leading one in a row echelon form. That means you have to do row echelon form first. And then you just count the number of leading one. You see? So the rank of this matrix gonna be 3 because we have 1, 2, 3, 3 leading ones. Okay, so the rank is the number of leading one in row echelon form already. All right, next one here. Like this example,